So welcome to the very first panel on the decentralized applications. We're going to have 4 panelists who are the speakers in the first session, talking about individual effort on decentralizing the apps. So the question is that why we want to talk about decentralized apps. So here's the thing, that is, first we have to agree on what's the definition of a decentralization. Some people think that decentralization means get rid of the clouds, or otherwise the infrastructure need to be cut into different pieces, things like that. I think that the fundamental thing about the decentralization is really the control power. Who has a say about how things work and has the control over individuals' data? With that definition, then we can look into how we can make the internet to decentralize the system, as opposed to the current situation where things seem to get further and further consolidated in terms of control power across multiple attitudes of things, starting from applications, the data, and then gradually the infrastructure as well. 4 years back, the decentralization of the Internet Research Group had a workshop. The workshop report is hanging somewhere. I think I'll put on the slides. I'll add on later. Where people did dive, really drove down into the specifics and to understand how the Internet started being a decentralized system, in the sense that not a single party had a control power over other parties. But over the years or decades, now became the current situation. I think that if we understood how we got here, then we can figure out a way to see how we move away from undesired consolidation direction. According to that report, the consolidation really started from application consolidations. And I think that's one motivations that people started the decentralization effort by developing decentralized apps. This morning we heard 4 very different efforts. So the goal of this panel, as we stated in the description, that is, one is that our collective understanding of today's efforts toward the decentralization, and what are the major roadblocks that making the decentralized application development challenging, and then articulate what are the future actionable items that we can tackle on. The 4 panelists, people already met them this morning, so therefore I don't have to do further introductions, so we can get the discussion started right away. So question for the panelists. I know that people ask the specific questions to individual presenters, but we probably did not have enough time. And then we can just start it, giving people opportunities to bring up the questions. You haven't got the answers yet. And here I got some questions, just warm up the conversation before I hit some more challenging ones. I talk about the different applications, right? Varun and the whole group actually talked about workspace only. And SASW talks about this secure, automated workflow application. Jesse talked about Solid. There's another application scenario we didn't present it here, but at the DNRG meeting, I think 3 weeks back, there was an excellent presentation analyzing whether Bluesky is a decentralized or Bluesky is actually partially centralized system. And I remember the presenter had the last slides saying that, is Bluesky decentralized? Yes, check mark. Is Bluesky centralized? Yes, check mark. So therefore, clearly we're facing challenges on how to build truly decentralized systems. And then what this panel is trying to dive further into it. I'll just stay at the first, at the specific application level to talk about, for each one, what do you see as the most difficult part when you try to design or deploy build your decentralized apps. Maybe I can just start it from the order of the presentation this morning. Warun, if you can recall, representing the workspace team to say which part in the whole development you found the most challenging.
Right. So I have two answers for that. The first is from the economic point of view, which is where do you find the resources to build these applications? And does not have a straightforward answer, but like you get funding from various sources, donations, government, and that kind of thing. But that is still, for me, it's an open question. From the technical standpoint, I think the most challenging issue on which we have a significant disagreement is long-term key storage. And really, a lot of these challenges building decentralized apps become a lot easier if you can make the assumption that people have keys, and people have private keys, and their public keys are well known, maybe from multiple sources, and then this key stays with that person, and then essentially giving that person some kind of stable identity. And it's this problem that we cannot have this kind of thing today is one of the reasons why building decentralized apps is so hard, because it makes the bootstrapping question a lot harder.
That's a great answer. I think that the second presenter, if I remember right, is actually SASW. I know that the SAW still states that the design stage is yet to be kind of tried out. But if you can recall this whole process of the development, which part you found is most difficult to actually sketch out to figure out how it works?
So technically, I think looking at the workflows and figuring out how to convert them to DAGs, and then how to generalize that's pretty difficult. Genomics, one workflow works. How do we take that and make it generalizable to different workflows, different communities? There's a concern that it might become a very specific solution and not a generic one. So that's the high level concern. The other concern is we don't really know the edge cases of these scenarios, the decentralized systems. So everything breaks at the seams. So what are the seams? That I don't think we have figured those out yet.
Thank you. I think everyone else, the audience, both in person and online, please feel free to speak up and ask all your questions. Otherwise, I'm going to continue on to Jesse. I know that Solid is a huge effort, has been going on for some extended time period. But if you could recollect to see what are the most difficult thing in the Solid development.
Phrase at the start, which is finding the right business models for deployments and applications of Solid is difficult because you are flying in the face of 2 decades now worth of .com monetization that has relied quite heavily on data siloing and targeted advertising on top of that. So finding the right business models for applications in the Solid ecosystem is a real challenge because you need to monetize or find a way of sustaining the applications that developers build and find a way of sustaining the storage, the pod providers as well. The pod providers is not an impossible challenge. Many of us pay for storage today with things like Google Drive. You can also attach it to adjacent services, like make it part of your internet plan or your mobile plan. But we're still discovering what the best business models are for adoption. For the fact that in Solid, applications are designed to be able to reuse each other's data, that does introduce a significant challenge for the decentralized or distributed use of data across applications, because I talked about this RDF data model as a way of getting consensus on the way that information is modeled. But that consensus process is very hard. I am sure if I had a conversation with many of you, we'd disagree on how to define a human, how to define core attributes, whether it's to do with identity, different governments, different cultural groups, different religions have a different idea of what gender attributes to assign to people. There's different ways that we'll conceptualize the way a system works, the way a medical institution might work. So getting to that point of shared data models so that applications can have a shared understanding is very difficult, and not just a technical challenge, but a political challenge of trying to get people and developers to align their worldviews.
Thank you. I think Tianyuan put in a kind of odd spot. He actually talked about comparing the implementation. Well, one is a trial implementation to see, can we do something like only over the TCP/IP protocol stack? The technical difficulties. And he tried to explain how that difficulties went away if you just think differently by building the application over the NDN delivery model. But here on this panel, because we didn't find a person to speak for the Bluesky due to the time constraints, the DNRG speaker actually in China, it's really odd time for them to be online. So therefore, we had some exchanges with the Bluesky people. In particular, remember the Connex, the Bluesky presenter at the workshop. We just had some recent email exchanges, and Tianyuan had dived into the details of Bluesky something. I don't know whether you can say a few words. Just we're not putting the words into Bluesky's mouth, but based on our understanding, why the concluding slides on that DNRG presentation end up by saying Bluesky is partly decentralized and partly centralized. So the question is, why that is the situation?
So I think we should first start from what is the basic components of the Bluesky. So Bluesky basically says, instead of having a user identity, your user handle is an actual DNS name, but that handle is only for so-called display purpose. That handle will be bounded to you can say that's the key identifier called decentralized identity called DID, and that DID you can essentially say that is the key identifier is the real user identity, and you can have and you can for data you produce, like the post, the likes, the following, you can that is also a data, a signed data, and those signed data are stored in the so-called personal data servers, and Bluesky provide the relay to actually pull the data from every individual personal data servers and produce a live stream of user activity. And there are some small individual so-called feed generators to actually generate curated feeds for individual so-called clients or Bluesky users. So that is the basic structure of Bluesky. And the observed so-called centralization of Bluesky is that because most of people, they don't have DNS names. So Bluesky provides an option saying if you don't have a DNS name, you can register, so-called register under my domain I think .bsky.social. Yeah, .social. But that so-called domain, you don't have actual so-called DNS access under that domain. It's more like assigned username, and that presenter at the DNRG says this is a centralization issue that we should be aware of, because most people, for convenience, because they don't have DNS name, they just be registered under the Bluesky. And another issue is about the relay. First is the incentive question, that is who will run the relay. For example, Bluesky itself is so-called a free application. Then other than the Bluesky so-called developer themselves, who has incentive to run the relay? That's the economic question. And the second technical question is, even if you have the incentive, how you gather information, you still need to prove because today's reality or practice is that you have a server there, and that server talk with individual servers to pull data and produce a so-called live stream user activity on another URL that basically says this relay is a single thing. So the presenter at the NRG says there's two observer centralization issue. One is as the relay part, one is at the identity part.
Thank you. Now I want to do some, not cross-examination, but bring question from one application to another. Varun mentioned that there are two challenges as he observed in the effort. One is the support of where comes the funding to support this new direction of application development, and that seemed to be a shared concern with Solid as well, right? Where's the business model to push the new direction? But when Varun mentioned the second one, that is currently the lack of identity for individuals. Identity means you need to have a name and need to have associated crypto credentials. That seems to be one challenge in develop secure distributed applications. And that seems to be reflected in Tianyuan's understanding analysis of Bluesky as well. That's how Bluesky end up with facing all these millions of users that do not have their own identity. Bluesky end up with giving them a name under Bluesky and then manage their crypto credentials on their behalf, instead of having individual users managing their own crypto credentials. However, I didn't hear this issue being mentioned in the Solid development. Is that right, Jesse? Or that wasn't the question?
So
you have magic to solve it?
A bit. And I'll start by saying that the space of self-sovereign identity has a lot going on in it. And we want to distinguish between the discussion of identity and identifiers. So an identifier is something like a username or a URL or a DID that can be used to refer to someone, but that is not your whole identity. Your identity is more or less a set of attributes with which one can be established as an entity that you care about. And online, we also have quite often different personas. A lot of people have finsters, for example, so you can have multiple identities online and have different attributes associated with that identity. And when it comes to the space of identity, I would encourage, if you haven't already, those people who are addressing the identity challenges to look at what the Decentralized Identity Foundation is working on, which is a Linux Foundation initiative, and they're addressing identity in a range of ways, one of which, and the most widely adopted at the moment, is verifiable credential-based solutions that allow signatures on DIDs, which is what Bluesky uses in part. But that verifiable credential standard does not rely on a particular DID method, and you can sign in various ways. So for Solid, the current identity mechanism used by Solid is OIDC, well, previously OIDC, now user managed access, UMA flows, which means that it's the same standard that Google and GitHub and all of your single sign-on flows use, which means that there is some identity provider that you're reliant on in the current standards. The difference with Solid is that you have choice over your pod provider, and hence you have choice over your identity provider. So you have the option to host your own pod on your own machine as a server, and then your machine becomes your identity provider in that world. I will also add to that, and the reason that I led with this discussion of self-sovereign identity is that in the linked web storage group, we're looking at creating affordances for a range of different authentication mechanisms to allow for non-OIDC based authentication to be part of the future of Solid. Thank you.
Looks like there are different ways utilizing so-called identifier. I would not talk about identity if you consider identity as just a collection of attributes associated with identifier. Now I think it comes down to the question, how is identifier get used in building decentralized applications? As we saw this morning from the Ownly presentation, that is the foundational building block, right? That's utilized to identify individual players and directly associated with the data produced by individuals. And in addition, it's used in communications because name the data networking, just take that name and distribute the data to whoever wanted the data under that name. Looks like Solid, on the other hand, utilize this so-called identifier in some fundamentally different ways. Instead of it plays the role of identifying, plays the role of security, and plays the role of communication. Instead of that, I think Solid use the identifier exactly at which level and for what purpose.
So the current the primary identifier that's used in the Solid standard at the moment is called a web ID. And that web ID is a URL that refers to you when you go to that URL. And it was the document I showed on one of my slides. You get back a set of data that contains information about your issuer, about where your data is stored, and about other information. That's awesome. And we acknowledge that in the current standards, that means you're reliant on the DNS system and you're reliant potentially on a service provider to provide your identity if you choose to have a pod provider that is not hosted by yourself. So in the current community standards, your identity is tied to DNS. In the linked web storage standard, which is maturing the Solid client to server specification, we're looking at allowing other methods, including potentially DIDs, so that there are ways of having identifiers that you can dereference that are not tied to the DNS system.
Thank you. Okay.
Yeah. Jesse, I think you talk about like you have URL linked to your profile. My question is, who provides the resource to host that URL?
So this is your what we call a pod provider. In the early days of Solid, it was envisioned that you would be your own pod provider. So you would download an open source repository, a node Solid server, spin that up on your machine, and then you're serving that resource that is your identity, and you're serving the resources that is all your data about you. So when you go and log into a Solid application, that is actually fetching data on your machine using your server. Now, obviously, most non-computer sciencey people are not going to want to self-host. So then it is a pod provider, which is essentially a cloud service provider that you're delegating that to, and what type of entity hosts that is up to you. So we've looked at potentially having traditional cloud providers are one option, obviously, as are financial institutions because they're trusted with financial data. So there's a range of options for who can be that host, but you have the option to self-host.
So can I say it's similar to Bluesky that most of users are using a so-called provider to host their so-called identity. And although you have options to opt out to have your own so-called self-hosting things, but most of users are relying on like a so-called provider. Is that safe to say so?
Yeah, it's a very similar paradigm, yes.
I think we should identify both the differences but also commonalities, because they're really shared basic options. For example, Solid also, I would call it a data-centric system, right? The focus on the data, on the storage, and utilizing the semantic naming URL to help the move the data around. I think that's also the same idea in SASW's talk. He actually further, if I say it right, further extended the notion of not only you use the names to identify a piece of data, but also identify the functions where everything has a name. It's all about association between the different names, and use that to drive the workflow. Did I get it right, Sashmi?
Yes.
And for this use case, the identifier is important, but not in the other, not like the other two. Here, it's doing the matchmaking between the request and the resources. Of course, you want to have authorization and all the other things, but who this actual person is, it matters a little bit less, because all you care about getting your computation done. So when a request comes in, look at the attributes. We're talking about the same things, really. And then you say, well, does these set of attributes have the proper authorization to run the compute on the service?
Thank you. Thank you. I think everyone should chip in to present your views. Which one, if you have some questions you want to bring up?
Yeah, I have a question for Varun.
So you talk about the difficulty of having persistent user identity, but in the NDN workspace, how you solve it? And will that matter, whatever solution you have, can you generalize and apply to others?
Right. So in the workspace, we're not really doing something new. Essentially, the way that people have solved this identity problem right now is push that problem into someone to someone who can do it, which is today it is password managers. You let the password manager manage all your passwords, and then you only prove your identity once to your password manager using some maybe a token, like you can have backup tokens and stuff like that, or some form of authentication, like a password for itself and a second factor of authentication. But essentially, the current implementation of Ownly pushes that problem to the email system and to the testbed root of trust. And so you have an identity verifier that kind of verifies this identity that you use to bootstrap onto the workspace. And if you can do the same thing again, doesn't have to be the same verifier, but if you can do the same thing again, then that proves that you're the same identity. But again, this doesn't really solve the problem. It moves the problem to someone else, someone who can do the key management. The key problem is normal users cannot do key management. They cannot maintain the stable long-term key that they can use across different applications or even for one application. And so you make someone do it who can do this key management, which is in this case the testbed or whoever is the identity verifier.
Yeah, if I pick up my moderator's role and just join the conversation. I had the thought that what's currently this verification has two issues. One is identity, or identifier, I should say, by the Genesis definition. We talk about identifiers. Email works, that's how all the applications, most of the applications today use to identify human users. There's a hidden question, which is who allocated or assigned that email address to you. If this scattered over 3 million organizations, whatever, so therefore that seems to be a fair game. But currently, I think there's very small, less than a handful of major email providers that actually provides the email addresses for, I would say maybe 90, 95, or even above the users in the cyberspace. So that would be a concern. The second thing, so there's the identifier thing. And Tian Yuan's talk pushed the direction of, can we use the DNS names? One may ask the question, what's the difference between email as identifier versus if you get the DNS name? By the way, DNS name, I think one should get rid of the notion that it's so hard to get. It's so easy to get. So this only does work. Just group just got it for really inexpensive. I wouldn't say how much it is. But the point is that DNS namespace supposedly should be just an independent namespace, independent from specific applications or application providers. And therefore, you can think of the mutual namespace that one can use for all the different scenarios without being controlled or constrained by that identifier provider. So the identity is one thing. The second thing is this identity verification. I think I wouldn't know if that's a very difficult problem to verify you are the owner of a name. Like Let's Encrypt seems to doing that in a pretty scalable way. Of course, it's not bulletproof. One could somehow, if one want to, attack that system for verification. But then you mentioned the third thing, which I want to ask you a question. You say that the general users don't really know how to handle the crypto keys of their own. That is very true. I thought the NDN effort is actually meant to develop the tools so that no human users have to directly deal with the crypto. Instead, you provide an intuitive UI to enable users to manage their keys. So therefore, I don't see that as like intrinsic problem. I think I agree on the namespace. It's a big challenge, but there's a direction that's pushing DNS. I think it's a I would say feasible direction and probably the most promising direction to push for. And identity verification is doable, and key management is all about the tool development. I don't know if you agree.
I had a comment on key management very quickly, which is if you have been using websites over the last 6 months like GitHub, you may have noticed that you can now do this sign in with a passkey process. And a passkey is doing key management for you and signing for you. So there is, after several decades of the key management not being supported by browsers, there is now support starting to come in through the WebAuthn API. And I was wondering whether you're looking into using that infrastructure as part of NDN.
I think that's a great point. I personally haven't used. I've read about passkeys, but I haven't used the newer implementations. But anything that really helps you have a long-term key that is tied to your identity will significantly simplify our entire implementation effort. It doesn't have to be like forever, but even if it's like relatively stable, I think that solves a lot of our problems. That's more or less, that is what I was getting at. I'm not saying that these problems are unsolvable. I'm saying that they just become much harder when you have to deal with continuously changing keys, that a user keeps changing keys, then it's a much harder problem. And I think passkey actually does try to solve part of that problem.
In a decentralized scenario, who runs the server? Who provides the challenge?
If I give a quick answer, I think the challenge is about your identifier verification. Right. But that should be done once once it's verified, your Ownless identifier, that doesn't have to be done repeatedly. For every instance, every application, you have been proven to own this name. You have a crypto key associated with it. Then you can just present the pair, the name and the key, to different application instances. Of course, for each application instance, you should produce a new pair of keys for that specific application to minimize, I would say, this least privilege principle by the security people. Right? For every key is a very limited power. Anyone else want to chip in now?
I was saying that I don't think we can directly use WebAuthn. WebAuthn and passkeys solve a very big problem, and it's a great technology, helps a lot with traditional web applications. I'm not sure if we can directly use it in a decentralized application. There may be the fact that it's been integrated in browsers help us on the, I don't know, key storage problem, or generally speaking, cryptographic material, storing cryptographic material on the browser in a secure way that you can unlock and use through some other, biometric authentication maybe. But I think there still has to be a party that when you do the initial enrollment, so I'm not sure how that would work.
You need a party to do it.
Right. So that was my question about who is doing the challenge, right?
Yeah.
Yeah.
I think another way to interpret this is like, analogy is like when you do email challenge, who will send the actual email, and do the email challenge. I think it's exactly the same question for WebAuth.
Yeah, I think the WebAuth provides another way to validate the user's identity, but you still need the rest of the, you need some trust anchor or some way of establishing this trust through pre-existing trust relationships, and so that ends up with this some kind of CA which will issue you the cert, which then can use WebAuth, but it doesn't solve the whole problem for sure. I think some of these, you need to start with some pre-existing trust anyway, and that thing needs to verify you.
There's a comment I wanted to do earlier. Okay, we can discuss about this and the technology, but I think we should actually step back or up a level. What is the problem here? I mean, why is this a problem even? Why do we care that, okay, there needs to be something that verifies some identity at some point? There can be multiple ways to do it. Like, okay, what is the problem? Why is this considered a problem?
Is we want to, from my point of view, we want to have this more concrete. There can be multiple ways, but what are the effective ways to do it?
I'm more about this in the call. You can do, I don't know, I prove I have a domain, I can prove I have an email, I can prove I have a phone number, I can prove to you I'm somebody by a QR code.
Right, but the strongest proof that you can give is if we already have a trust relationship and you have a key, then that is foolproof. And so then you only have to do that once. If you have this long-term key, then we can meet up, we can do it right now. And now we'd never have to do it again if you can maintain that. It solves a lot of problems.
This is a solution?
No, I'm saying
Web of Trust, the GP Web of Trust 19.
That's what I'm saying. The problem. No, that's the problem. That we cannot do that.
Yeah, I mean this is not a problem because it cannot be solved. Period.
Well, I think this conversation may take a longer time. We can take it to the lunch. But let me summarize.
I think this is the
I think that if I got the point right from Varun, it's really, if everyone has identifier with associated crypto keys, then you can establish secure communications or produce data to put the security on your data automatically without having to worry about how do you verify my identity, where do I get keys, how do I get certificate for my keys. If everything is already existing, you don't worry about those things. Think about the analogy, like the internet. You run email, you run web, you don't think about, how am I connected? Where do I get IP addresses? This provided by the system automatically. The things they don't worry for your individual application usage. Okay, it's there. Your connectivity is there. And we want to get into the same scenario if I make an analogy right. Your identity, your crypto key, the certificate is out there. Anyone try to communicate with your security, just like as easy as sending a packet out. Because nothing you have to figure out at the
You're
time.
agreeing with me.
I agree with you in the sense that this wasn't needed. I don't agree with you in the sense that the current PGP can be used this way. We currently, I think the number one thing is we need to agree on the namespace. What is that identifier space for all the users? And maybe additional for other things as well. Without agreement on that identifier space, it's hard to say what the key, this crypto key is allocated to. A key is bound to identifier. And what is that shared identifier space for everybody? Yeah, then you can do the probability of the truthfulness. Okay, you have final words, and we'll move on to the next topic.
I think I'm not trying to say that it's a new problem. I agree that this is what PGP tried to do, but the problem is it's not usable, and I'm saying it continues to be a problem, pretty much.
So there's only 15 minutes left before 1 o'clock. Let me bring up the second topic, which is another issue I heard this morning about client server. I remember hearing Jesse talking about solid support this client server model, also client model. Well, in the only presentation, I don't think people heard the word client server otherwise client to client. Instead, because only is built on top of NDN, the so-called model is really publish and consume of data. Are these two models the same thing, the different thing, compatible? What's the future we're moving into? So that's my broadly defined question. So I'd like to get the opinions from the panelists.
In terms of client to server versus client to client, client to server is where most of the communication is happening, and it's using the traditional REST architecture, where clients are going and fetching resources from servers and then interacting with that data. When I talk about client to client contracts or standards, that is not about web applications directly communicating with each other. That is about clients using the same data models when they read and write data to the servers, so that my Jarvis application can write information about my address, date of birth, and family and put that on a server. And then your Laravel, or let me think of a good name, your Poly application can go to that server, fetch that data, and understand what that data means. So at a transport level, it is fairly strictly client to server. And then at a semantics, at an understanding of data level, the importance is clients understanding the data that they're reading and writing has the same data model.
If I ask one more question, do you think that this client server and the client can they be actually adopted, or actually they are kind of match up to this publish produce model as well? Because think about what's the client, what the data. It's all about someone produce data, some others consume the data.
I think it depends on the problem space that you're trying to solve. The reason that, or one of the reasons for the successes of the web is various parts of the REST architecture have allowed for scalability of content delivery and scalability of applications. For instance, the way that resources are made available allows you to have caching, allows you to have CDNs, so allows you to distribute the same resource to hundreds, thousands, millions, billions of different client devices at once. And I'm unclear on whether the publish consume model that exists for direct client-to-client communication with the publish-consume model would be able to operate at the same level of scale. So I think continuing to use the REST architectures is one of the benefits to Solid, and I really haven't thought enough about scalability in the context of publish and consume and NDN, to be honest.
Generally on the topic of client server, from a high level, I think we have to separate services and infrastructure. And what really separates this is like there can be something running in the cloud or running somewhere, like a bunch of servers, racks, machines. But the question is, do they deal with the application security, which really differentiates services, servers from just infrastructure? And if the problem is if they do deal with application security, then they will do some kind of gatekeeping, like whatever data is in there, can someone access that? If it's the service doing this, then that I think is what causes all the problems and leads to centralization, because essentially it becomes a control point. And now even if you can run your own server, which is running there, one of the problems is that most people are not going to do that. So that leads into the Bluesky problem, that it ends up being centralized again because the server is doing the gatekeeping. So I think that is the direction that we need to move away from, that we can use infrastructure. Infrastructure is not a bad thing, but that infrastructure should not gatekeep who does what at any point, whether it be you can run the infrastructure or not, or whether it's in the cloud.
Well, there's some places where gatekeeping is necessary, right? I mean, you don't want the sensitive data to be publicly available. I mean, the legitimate use cases for privacy and secrecy and all that.
So what I'm saying is that that can be done at different levels. Like the way that Ownly tries to do it is you encrypt the data before you put it into the untrusted infrastructure. And so that means even if you do get the raw bytes of the data, they're encrypted. You can't do anything with that. So that stops it from being a gatekeeper.
Not today, right? But someone can take a dump of the data, keep it for crypto analysis, and eventually at some point they can break it. So there are those concerns as well.
Yeah, I mean, I agree with that. But so from a, like if you are in the network, if you assume that the adversary can capture packets always, then it's like true either way. Even if your server can gatekeep, your adversary can be somewhere between the server and the client and still get the encrypted data. So I mostly agree, but I'm saying that it's a problem either way.
I don't know if opening up everything is the solution. I think there's if you go talk to the application people, they would say we don't really care whether it's underneath it's client or server or peer to peer. All I care is I get to do my research, or I get to watch the video, or whatever they're doing. How we build the systems for those use cases, that's a different discussion. And I suspect there will be both places for both client server model and peer-to-peer model in that future. To me, client server it's a subset of peer-to-peer model, right? So you have two peers. But do you want to build all the scaffolding around it just so that two peers can talk to each other? Probably not, right? So tools based on what you're using these for, you might choose the client server model, you might choose the peer-to-peer model. But I don't think we need to decide which way we want to go, whichever fits the use case.
I'll second that. And quite often when discussing Solid, we don't use the term decentralization. Instead, we use the term user centralization of data, or re-centralizing the data around users, which kind of sidesteps that debate a little bit. The point that you made as well, that we need to consider the end users, we need to consider the applications, and we need to consider the use cases, I think is very important. And having spent a lot of time in standards bodies and having spent a lot of time in development communities, we and I am very much a culprit of this, I think, find that as developers tend to build for the values that we consider to be most important. And if you look over at some of the humanities literature, and I'm in kind of a human-centered interaction space at the moment, there's a lot of work that has been done, firstly around building methodologies like value-sensitive design, to have a methodology to say, okay, we're building an application, who are our stakeholders? And that might be individuals, indigenous groups, governments, banks, whoever. Okay, what do they want to get out of our infrastructure? A lot of the time they will want privacy, especially if it's, say, an indigenous group that's had a history of bad interactions with the government. They want privacy and control over that data. There's people in the CS world who also want a lot of privacy and control. But there's other values that people want as well, like accessibility, transparency of data, ease of use. So I kind of encourage us as developers, computer scientists, standards developers to every so often take a step back and think about why we're building the systems we're building and how we can kind of direct ourselves to consider the end users more as well.
Yeah. I think there's a cool computer science problems, and then there are user problems, and they're not always the same.
Yeah, I fully agree with that, and especially the idea that there's no one size fits all. So we will have different designs that fit for different use cases. Yeah.
So I will just say a few words and then Tina can talk. I think that there seems to be some conceptual clarifications necessary. Like when we say peer-to-peer, let's not interpret that as a BitTorrent peer-to-peer, just swapping files. When we say peer-to-peer, means that the parties are equal. For example, for Ownly, there's a peer-to-peer. Each entity is both a producer and a consumer. That is both a client and a server, right? The fundamental thing about service is not service. Service is great. We definitely need servers. There is this notion that there's this, and I just to clarify peer-to-peer. It's not BitTorrent peer-to-peer or swapping files. A peer is both a server and a client. This kind of shared services, I think, has the potential to somehow less likely to be centralized if there's multiple clients that depend on the server. And the trend over the years is that the service tend to be consolidated. That is what we have seen. A service definitely is needed, it's great, but there is that potential there.
I think if you look at from pure application design level, for example, Bluesky, even they have a very strong notion of so-called servers. They have personal data servers. The term server literally in the names really is our servers. And if you consider pragmatically, most feature generators are servers. But if you look at from their API levels, they literally says subscribe to individual so-called user repository, subscribe to whatever feed generators. So I think from an application design perspective, there are some applications like more suitable to this producer consumer model. And I have a hypothesis, not with a strong evidence, but my hypothesis is that the system could be designed or implemented with a simpler structure or architecture if the underlying communication paradigm matches how applications are designed at the upper level. So I agree with the control argument with Lisha, that is, you have multiple clients depends on server, the server tend to be concentrated or centralized, consolidated, but I'm saying even you think from so-called system even think from first intuition, choosing a communication paradigm that better matches the application design seems to be a better option.
Anyone else? Otherwise, if I say that all the panelists has a final words, can each one would like to say something? One sentence of what you walk away from this panel. Or what do you want the audience to walk away from this panel?
My takeaway from this panel is there are a lot of interesting things being built. There is a live and thriving diaspora of decentralized technologies. And specifically for Solid, I'll say we are at a point where we are ready for people to build applications. So if you want to explore Solid, get involved in Solid. I've put links to our community in the chat. And please do get involved or reach out or ask questions if you want to. And thank you for having me.
Thank you. Yeah, for participating.
Yeah, I think I can go next. With all the research in decentralization, I think there's still a lot of research to be done. But more importantly, I think there are a lot of cool applications that can be built in a decentralized way. So if you're looking to collaborate, we are happy to talk.
Thank you.
Yeah, I want to just mirror what Susmit said, that in a maybe slightly different way, that to approach the problem of decentralizing applications, we have to look at applications. And to understand problems that these applications have, we have to start not by building the technology that we anticipate that the application needs, but actually try to build these applications and get people to use them. And so I think we need to push for building these things, getting people to use them, and then doing this feedback loop rather than going ground up. So yeah, if you are willing to contribute to any of these projects, please do. It's more than welcome.
I would agree with Varun that we should continue this application-driven approach, because only by building so decentralized application and practice them, observe the problem, you can get better understanding. And also, I want to say, we also need to think about what is the so-called right economic model of so-called decentralization, because no one wants to do free work. How this thing work? Who will provide resources? Those kind of problems.
Thank you, everyone, for the audience and for the panelists.
Thank you
Thank you very much.